In a variable primary flow, or VPF system, both the primary equipment and the distribution loop experience variable flow. This design allows the system to efficiently match pump energy and equipment operation with real-time load demands. Let's break down how it works. First, variable speed pumps are installed on the primary loop. These pumps are equipped with VFDs that modulate their speed based on system demand. Next, the flow passes through the chillers, boilers, or heat pumps, depending on whether the system is used for cooling or heating. Because the flow is variable, two-way automatic control valves are installed at each terminal unit, such as fan coil units, air handling units, or hot water coils. These valves open and close in response to the zone load, controlling how much chilled or hot water flows through the coils. To protect the primary equipment, a bypass valve is included. This valve ensures that a minimum flow is always maintained through the chiller or boiler, even when most of the terminal valves are closed. A differential pressure sensor is typically installed at the farthest terminal unit. It monitors the pressure difference between supply and return lines. The VFD pump then adjusts its speed automatically to maintain the desired differential pressure, ensuring that just enough water is circulated to meet the load. No more, no less. This setup eliminates the need for a secondary pumping loop, reduces pumping energy, and improves overall plant efficiency. The flow meter in the return line helps monitor total system performance and verify chiller or boiler loading. In a constant primary and variable secondary flow system, the primary side maintains a constant flow through the chillers, boilers, or heat pumps, while the secondary side varies based on the building load. Let's look at how this system works. The primary and secondary loops are hydraulically decoupled by a common pipe or decoupler. This means that changes in flow on the secondary side do not affect the flow through the chillers or boilers on the primary side. Primary pumps are dedicated to the central plant. They are sized for the equipment flow requirements and the pressure drop through the chillers or boilers. Secondary pumps, on the other hand, are sized for the building distribution system. These pumps operate with variable frequency drives, adjusting their speed to match the demand from the terminal units such as air handling units, fan coils, and chilled water coils. As the building load decreases, the secondary pumps slow down, reducing energy consumption. However, the flow through the primary equipment remains constant to ensure stable operation and proper heat exchange performance. When cooling towers are used, operating them at 50% water flow with fans running at 50% speed can use significantly less energy than running at full speed. This highlights the energy savings potential of variable secondary systems. It's also important to use at least one three-way control valve in the system to prevent deadheading of secondary pumps when all two-way valves close.